Good morning to all of you. Myself, Mithilesh Gautam, working as assistant professor in SIRT College, Bhopal. Today I am going to discuss on the topic of armature reaction in DC generator. First, we know what is the armature reaction. The armature reaction simply shows the effect of armature field on the main field. In other words, the armature reaction represents the impact of the armature flux on the main field flux. The armature field is produced by the armature conductors when current flow through them, and the main field is produced by the magnetic poles. And the armature flux causes the two effects on the main field flux. First one, it distorted the main field flux, and second one, it reduces the main field flux. First, we discuss some important topics of important points of the armature reaction, MNA and GNA. GNA is the geometric neutral axis that bisect the angle between the central line of adjacent poles, and the magnetic neutral axis. It is the axis that drawn perpendicular to the mean direction of the flux passing through the center of the armature. First, we consider the figure. In this figure, only field currents are present, and the armature current is zero. When the no load is connected to the generator, the armature current becomes zero. In this condition, only the MMF of the main poles exist in the generator. The MMF is uniformly distributed along the magnetic axis. The magnetic axis means the central line between the north and south pole. And the arrow in the below given image show the direction of the magnetic flux phi m. The magnetic neutral axis or the plane is perpendicular to the axis of the magnetic flux. And the MNA coincide with the geometry neutral axis, and the brushes of the DC machines are always placed in this axis, and hence the axis is called the axis of commutation. Second case, when in this case only armature currents are present and the field current is zero. Consider this condition. In this condition, only armature conductors carrying the current, and no current flow through the main poles. The direction of current remain the same in all the conductors laying under one pole, and the direction of current induces in the conductor is given by the Fleming right hand rule. And the direction of flux generates in the conductors is given by the Corpuscle rule. The direction of current on the left side of the armature conductors goes into the paper, represented by the cross inside the circle, and the armature conductor combine their MMF for generating the flux through the armature is in the downward direction. Similarly, right hand side conductor carry the current and the direction goes out the paper, shown by dots inside the circle. The conductors on right hand side is always combine their MMF for producing the flux in the downward direction, and hence the conductors on both sides combine their MMF in such a way so that their flux goes downward direction. The flux induces in the armature conductors phi a is given by the arrow shown in this figure. Now consider the figure. Now in this figure, so the condition in which the field current and the armature currents are simultaneously acting on the conductor. This happens when the machine in this condition, when the machine has two fluxes. First one is the armature flux, and the second one is the main field flux. The armature flux is produced by the current induced in the armature conductors, while the field pole flux is induced because of the main field poles. These two flux combines and gives the resultant flux phi r, as shown in the figure. When the field flux enters into the armature, they may get distorted. The distortion increases the density of the flux in the upper pole tip and of the n pole and the lower pole tip of the south pole. Similarly, the density of flux decreases in the lower pole tip of the north pole and the upper pole tip of the south pole. The resultant flux induces in the generator are shifted towards the direction of the rotation of the generator, and the magnetic neutral axis of the pole is always perpendicular to the always perpendicular to the axis of the resultant flux. The MNA is continuously shifted with the resultant flux. There are some effects of the armature reaction. First one is the because of the armature reaction, the resultant flux because of the armature reaction, the flux density of over one half cycle of the pole increases, and over the other half cycle it decreases. The total flux produced by each pole is slightly less, due to which the magnitude of the terminal voltage reduces. The effect due to which the armature reaction reduces the total flux is known as the demagnetizing effect. The resultant flux, the resultant flux is distorted. The direction of the magnetic neutral axis is shifted with the direction of the resultant flux in the case of generator, and it is the opposite to the direction of the resultant flux in case of the motor. The armature reaction induces the flux in the neutral zone, and this flux regenerates the voltage that causes the commutation problem. The MNA axis is the axis in which the value of the induced EMF becomes zero, and the GNA divide the armature core into the two equal parts. Thank you.